this is a short vid. What I've done is I've added a buffer capacitor here. It's in parallel with the series stack. Negative is still the RPS relative potential here at the 12 volts between the negative on the parallel stack and the negative on the series stack. Instead of using an inverter, I am now using just this DC oscillator. The DC oscillator in its configuration and in this particular coil layout, which is a trifilar coil, all co-wound on a common axis. The output from the third winding goes out through two half-wave bridge rectifiers and charges these two capacitors up, and then that's what would be discharged back into here. So this is about 2400 UF capacity. These are 14,000 UF at 100 volts each, so 7,000 UF at 200 volts. It's about 2 times, 3 times this capacity. But what I'm going to show you is I'm going to turn on the power. This switch is the power for this oscillator to charge that capacity, but it's currently shorted from this capacity back into the series stack. So it's turned on. The oscillator is running and charging this capacity. The voltmeter is over these two capacitors that are in series, and these are sitting at the 25.07 volt potential. So this connection right here, if I disconnect this connection, we'll watch the volts climb there as a result of the roughly 100 milliamp draw. So let's see if I can make this work with one hand. So you can see it's charging. I'm shorting it out periodically there. Let's see if I can get the shorted. You see the amp draw go below 0. So you size that capacity a little different, and we'll get a lower voltage, or a higher voltage more quickly. Anyway, put that back in there. It's back in there. And we'll shut that off. So, I mean, technically, or maybe in theory anyway, there's a draw, right, to charge the capacitor, which is at that mark. And then that would be disconnected. The buffer cap would feed that still for a amount of time, and then while that's disconnected, this, which has been charged up and is still being charged by this buffer cap, depleting to fill these capacitors still while that's disconnected from the series stack. These will then discharge back into the series stack, right? So it's an avalanche. So you end up with series stack to parallel stack generating the relative potential, which allows this to discharge but charges this stack. This potential that's being discharged is oscillating the DC oscillator, which is then charging these capacitors, and the charge in those capacitors is coming up higher than the voltage of the relative potential, which makes it higher than the series relative voltage. It needs to be higher than the 25 volts by at least 2 volts generally. And anywhere higher than that's kind of fluff. Depends how you want to couple it or impedance match it. But the idea being that as long as you can get a voltage higher than the DC voltage here, you can then charge the series stack back up, and then it's just periodic timing between the switching between the buffer cap and then to the discharge of these caps. Anyway, that's the idea. So the next thing is a sequential 2-slice or 4-slice timer to control the alternate switching.